Hi, hello. So I have been continued to study the eBPF technology. So today I wanted to talk about eBPF XDP SYNPROXY. So if you search in the Google XDP SYNPROXY, you will find this PDF link, which is here. So in this slide, it talks about accelerating SYNPROXY with XDP. So what it is SYNPROXY? So we can read about this slide, but let me just show you a diagram here. So this is SYNPROXY in action. For example, so here is a firewall. Here is the client, or it can be an attacker, and this is the server. So the firewall is to protect the server, and for a legitimate client, if the client wanted to send a HTTP, send a web request to the server, the firewall will examine the TCP three-way handshake. So TCP three-way handshake is here. The first packet is the SYN. The second packet is in the scenario of SYNPROXY, the firewall will send a SYN-ACK with a cookie encrypted with the SYN information. And then the client will finally act the SYN-ACK to establish the TCP collection. And so if the so when the ACK come back, the firewall think the client is a legitimate client. The firewall will send establish a TCP collection to the server, use TCP three-way handshake, SYN-ACK, right? So this is how the firewall works in the SYNPROXY scenario. So when the client is an attacker, and usually for SYN flooding, like the attacker can continuously send the SYN packet to the server, and without sending ACK, so it's just send the SYN and forget about it, and no ACK. So the firewall is supposed to protect the server by send a SYN-ACK with a cookie. And if the attacker does not respond to this SYN-ACK cookie, then the firewall will drop the packet. So on the server side, the server will not see the SYN packet, the SYN flooding to the server. So this is how SYNPROXY works on the firewall. So this is but in this slide, it uses the eBPF XDP to accelerate the SYNPROXY processing. And in this slide, it explains how SYN flood works, and how SYNPROXY works, and how the drawbacks of the SYN cookie with the existing implementation. Okay. Yeah. So I wanted to do a lab demo to just show how this SYNPROXY works on the firewall, and also use XDP to accelerate the SYNPROXY. So in order to do that, I need to find a Linux firewall solution. So I'm going to use a firehol, a Linux firewall, which basically use the IP table on the IP tables to set up firewall rules to protect the server. So specifically, I wanted to configure firehol with SYNPROXY to just get the basic SYNPROXY working without XDP acceleration. Okay, so here is my firewall server. Okay, so I installed the firehol project, and here is to configure the firehol firewall. The configuration is pretty straightforward. So for example, I have 3 interface on this firewall. And so this interface is for the management interface for the management network. And this interface is for my local home network. And this interface is for the internet facing network. Okay, so so before we configure the interfaces, we first needed to define the SYNPROXY configuration here. So what here means is here we only use IPv4 and with the SYNPROXY, and the input interface is the internet facing network, which is this one interface. It's the internet facing site, and that's the input interface. So that DST is the destination IP address on the firewall itself. So on the firewall, I have this IP address, which is in my lab sort of like a internet-facing IP address on this input interface, on the internet-facing interface 192. So the destination port is the port 80 for web HTTP port. And so if our attacker or a legitimate user wanted to access this IP address and the destination port 80, the SYNPROXY will do the destination address translation to an internal to a home server IP. This is the IP address in the home network. Okay, so just the one and the SYNPROXY will do the SYNPROXY protection and the destination address translation. And also here we have a router definition here in the firehol, and the router is from internet to home network. The input interface is the internet facing interface, and the output interface is the home network interface. And so here we have the server. Here means we will accept HTTP request to the destination address home network server, home web server. Okay, so that's all you need to configure a SYNPROXY on the firewall to protect a real server on the home network. And so again, yes, so that's this picture look like. So this is a firewall, this is my home server, web server, and this is an internet side client, right? So now let's do a test. Let's do a test. So this is my firewall. Again, my firewall has a three network interface. The internet side interface is ENS 192. The home network interface is ENS 224. So let's do a TCP down on the home network interface on the firewall. Or we only want to catch the web traffic. Okay. So this is a TCP down on the home network interface. And so this is our this is our real server, our home server. It has a home network IP address here, and this is a interface, and we can run TCP down here too. And to monitor the HTTP request. Okay. So this is our client. So first I will send a curl request. It's like a legitimate request to the firewall internet IP address. So again, this is my internet-facing interface, and it has this IP address. So we will send a HTTP request to this internet-facing IP address, and then it will the SYNPROXY will do the dnat translation to the real server home IP address. Okay, so let's just do that. Send a curl request. So you can see here the curl got the web page, and we can see the TCP down here. Hold on. Yeah, so we can see the TCP down on the real server, on the home server. We see the packet, the same three-way handshake, and the HTTP request. Okay, so this is on the firewall TCP down on the home interface. So we also see the same packet. Okay. So again, this is my client IP address, and this is the home internet-facing IP address, and this is a home server IP address. So you see it's denied from this IP address, this IP address on the firewall, to destination translated to this address, to the home server IP address. Okay, so it works, the destination translation. So now we wanted to do a SYN flooding as attacker. So here I only to the same IP address. Now I send only a SYN packet with HPIN 3. So this is sort of like a SYN flood attack simulation, but I only send one packet. Okay, so let's send one packet. And then let's see TCP down here on the firewall. As you can see, we do not see the SYN packet on the home network interface on the firewall. So what if we TCP down on the internet-facing interface? We should see the same packet. Again, this is our home server, so we do not see the SYN packet. Let's do it again to make it clear. So the client send a SYN packet, and now on the internet interface, we see the SYN packet coming to the firewall, and the firewall send a SYN ACK back to the client with a SYN cookie, and but on the server side, on the home server side, we still do not see the same packet, which means the firewall has done its job to protect the server if this is a SYN flooding packet. And right, so that's how it works. Like this picture, the attacker send a SYN, the firewall send a SYN ACK with cookie, but the attacker did not send the ACK because it's just wanted to do SYN flooding. And so the firewall protected the server because only after the three-way handshake established, firewall will send a SYN to the server. In this case, we do not see firewall send a SYN to the server because it is a SYN flood attack. So we can send more than one packet. Let's send a bunch of them. Flood. Let's send the real SYN flood, and randomize the source IP address. So now we will, if we see TCP down here, on the firewall, on the internet facing interface, we see a tons of a SYN flood coming here, attacking the firewall. So this is all the SYN flooding packet. You can see the source address is from random internet IP addresses to the same target firewall IP address, port 80. So this is not like a SYN flooding look like with randomized source IP address. And but on the server side, right, we do not TCP down. We do not see any of the SYN flood packet leaked through firewall to the real server. So the real server is protected, right? And this is SYN flooding continuous attack, and yeah, so it's still attacking. And so let's send when the server is when the firewall is under SYN flooding, let's do send a legitimate request to just make sure the server can the firewall can still function, and send the normal request to the home server. Okay, and let's do that test. And let's make it bigger. Let's send a request. Send a curl request. Okay, so this is a legitimate request, and we can see here it still works. So this is on the server side. And again, we do not see any SYN flood here, but we see the legitimate HTTP request. Okay. Yeah. So this is a demonstration of how SYNPROXY works to protect the real server. And so in my next video, I will use the I will show how to use the XDP acceleration for the SYNPROXY. And yeah, thank you.